Hello and selamat sejahtera, and today I will explain about experiment D2, which is flywheel apparatus. So we go to the result and we can see for the flywheel and axial dimension. For the flywheel, this diameter, the diameter is 0.3 meter, and for the axial diameter, the axial diameter is 0.025. For the flywheel depth is 0.04, and number of turns of string on axial is 8 revolution. And we can see the table for the drop time taken for each mesh from rest to minimum point. So in this table I calculate the average time. After I explain all the table, I will show you all the calculation that I have do to complete the table. So I will roughly explain about the how I get the average time. I get the average time by plus time 1, time 2 and time 3 and divide by 3, so that I can get the value of for the load 0.4, so that I can get by plus 15.94, 15.70, 72 and 15.78, and divide by 3, I will get the answer is 15.81. So this is the all value that I get, as you can see. Okay, next we go to the angular acceleration, linear acceleration and moment calculation. So all three, angular acceleration, linear acceleration and moment, we can calculate it using the equation given, and I will show you after I finish explain about the table. And the last table is by calculate m using a from the experimental table. So this table, the purpose of this table is to find the value of theoretical value of the moment. So I will roughly explain. First of all, we need to find the inertia from the disk and inertia from the axle, and then total plus that to the two inertia, the inertia from disk and axle, and we can get the I total, which is the total value of inertia. And after that, after we get the value, we can start proceed to find the theoretical value of the moment. Okay, next we go to the discussion. So the first question is, draw the free body diagram and kinetic diagram for the flywheel and weight. As you can see that I have draw the free body diagram of the flywheel and weight. So this is the picture that I have draw. So next we go to the question number 2. Compare and discuss the result of the drop time and moment of inertia for various weight of the flywheel apparatus using theoretical equation and compare to the measurement in the experiment. So that to compare this, first of all I make the graph first, so that we can easily understand how big difference between the moment of drop time and from the theoretical. So this is the graph, and as you can see they are a bit different. And for the theoretical moment of the theoretical, There are a lot of different between the result of the drop time and moment of inertia for various weight of the flywheel apparatus from the graph show that the theoretical value has higher value than the result of the drop time. And next, the last one, we go to the question number 3. Give you comment or suggest at least 4 causes of error that may affect the result of the experiment. So for this question, I choose to explain about the error. So there are 4 errors that I found in this experiment. The first one is systematic error. The systematic error are due to the identified cause and can in principle be eliminated. Error of this type of result in measure value that are consistently too high or consistently too low. The second one is random error. Random error are positive and negative fluctuation that cause about one half of the measurement to be too high and one half to be too low. Such of random error cannot always be identified. And number 3 is blunders error. A final search of error called a blunder is an outright mistake. A person may record a wrong value, misread a scale, forget a digit when reading a scale or recording a measurement, or make a similar blunder. This blunder should stick out like sore thumb if we make multiple measurement of if one person check the work of another. Blunder should not be included in the analysis of the data. And the last error is theoretical error. Due to the simplification of the model system of approximation in the equation describing it. For example, if your theory says that the temperature of the surrounding will not affect the reading taken when it actually does, then this factor will introduce a source of error. Okay, next we go to the conclusion. For the conclusion, the objective of this experiment are successfully achieved. We are able to verify Newton's second law for rotational motion, m equal to the inertia time angular acceleration. Determine the moment of inertia of a disk and exert from experiment. Determine the frictional moment required to overcome the friction, and determine the moment of inertia of a disk and exert using theoretical equation. Next, we are successfully able to conduct the procedure of the experiment and measure the result. Other than that, we are learned how to use and calculate the equation that given in this experiment to find the value of average time, angular acceleration, linear acceleration, and moment. Lastly, by doing this experiment, we are know the importance of the safety precaution in the laboratory. Lastly, we go to the safety precaution. There are 6 safety precautions that I know from this experiment. The first one is we must wear safety goggles. Number 2, we must wear lab coat. And number 3, wear suitable shoes. And number 4, follow the instruction given by lecturer. Number 5, do not eat in the laboratory. And the last one is ask when in doubt.